Hi and welcome to this introductory tutorial in relation to metric unit conversions for medication dosage calculations. By the end of this tutorial, you should be able to explain and demonstrate one strategy for multiplying and dividing decimal numbers by factors of 10. You should be able to use that strategy to convert between common metric units of weight used in medication dosage calculations. And you'll also know how to find further excellent resources to support your learning and to help you practice this skill. I'm going to do a quick recap now of the decimal number system. If you haven't already done the Moodle lesson on the decimal number system, I would encourage you to go back and revise that, because without a solid understanding of how decimal notation works, it's really hard to understand what you're doing with unit conversions. So please make sure that you are completely on top of this before moving on. So our decimal number system is based on 10 digits or numerals, and you'll notice that I'm quite deliberate about the terminology that I'm using here. The words digit and numeral are generally interchangeable, however, neither of those is interchangeable with the word number, and I will explain and show you why as we go through the session. So those 10 numerals are represented by these 10 very familiar symbols: 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. The value of any digit is determined by its position in a number. So on their own, these digits are not numbers. They have no value until they take up their place in a number. And this system of using digits and numerals to notate numbers is called positional notation, more commonly known as place value. In the decimal number system, each digit in a number has a value that's either 10 times bigger or 10 times smaller than its neighbour. So if a digit is one place to the left of the one next to it, it's 10 times bigger. And if it's one place to the right, it's 10 times smaller. It's sometimes helpful to go back to basics here and have a look at a place value chart, which shows how decimal notation works. You'll see down the middle we've got our decimal point, and then on each side of the decimal point we have our decimal numbers and decimal fractions. So going from the decimal point and working to the left, we have units, we have tens, we have hundreds, and we have thousands. And going to the right, we've got our decimal fractions: tenths, hundreds, thousands, etc. One thing it's worth noting, that's a common misconception that tends to throw people's calculations off, is that this isn't symmetrical. All right, there's no symmetry on either side of the decimal point. There is no equivalent of units to the right. We're straight into tenths when we're into the decimal fractions. And it's important to be aware of that, actually, because that can cause some problems with calculations. So, for example, if I put a number 4, a digit 4, in the units column, I have written the number 4. Okay, no surprises there. That should be something that you're all very familiar with. Again, if I put that number 4 in the tens column, it's essentially meaningless at the moment, because what it needs to make it into a coherent number is a 0 in the units column. That tells us we've got 4 tens and 0 units, and therefore we've got the number 40. Working with the decimal fractions, if I were to put my 4, and I do apologise for the wibbly wobbly mouse writing, if I put my 4 in the tenths column, I've got 0.4. I've got 4 tenths. Now, technically, mathematically, it's correct to write a decimal fraction like that, 0.4. Mathematicians would have no issue with that. However, in clinical practice, that would be absolutely horrible and dangerous, because it would be really easy to misread 0.4 as a number 4, which could lead to a massive overdose. So for nursing practice, you always need to make sure that you have your 0 in front of the decimal point when you're dealing with a decimal fraction. And we'll talk a little bit more about zeros in due course, because the number 0 is perhaps a bit more interesting than you've ever given it credit for. So there we've used a place value chart to show how the digits 4 and 0 can be used to represent 3 different numbers. The decimal point, as in our example here 3.526, you can think of it as signifying an AND. So it separates the whole numbers from the decimal fractions. Decimal fractions are just parts of a whole number. And in the decimal system, as we just saw, these parts are written to the right of the decimal point. So 3.5 equals 3 5/10. 3.52 is 3 52 hundredths. And 3.526 is 3 526 thousandths. Apologies if the word thousands there is obscured by the video of my face. Important to understand the link really between how these are written in words and how they're notated, because this is frequently misunderstood. A lot of people would look at 3.526 and think that that was 3 526 hundredths. It's not. Effectively, where your final digit lands tells you what fraction we're dealing with, and as that 6 would land in the thousands column, we are dealing here with 3 526 thousandths. Again, I'm always asking yes but why, and asking people to prove their answers and show their workings, so I'm going to go back to the place value chart here and just demonstrate using those numbers that I've just discussed. So if I write 3.5, I've got to put a 3 in my units column and a 5 in my tenths column. That's 3 5/10. Could also say that that was 3 1/2, but written decimally, that's 3.5. If I want to write 3 52 hundredths, I've got to put a 3 in my units column, a 5 in my tenths column, and a 2 in my hundredths column. So here we have 3 52 hundredths, 3.52. I'll just do one more of those to finish the job. 3 526 thousandths. Again, 3 in the units column, a 5 in the tenths column, 2 in the hundredths column, and the 6 goes in the thousands column. Because we finished our number in the thousands column, I know that that is 3 526 thousandths. Okay, so there's a whistle-stop reminder of the decimal place value system and decimal notation. Again, if you haven't got the quite got the foundations of this, please do go back to the decimal and metric units of measurement lesson and revise this. There's some excellent resources in there that explain it really well. Okay, so now we're going to turn and think about some of those really common SI units of weight which tend to be used the most frequently in medication dosage calculations and how to convert between them. I've illustrated those on this infographic here by means of a ladder. It can be quite a useful way of remembering whether you're going from a smaller unit to a larger unit or from a larger unit to a smaller unit. You do have to know your ladder. There isn't really any way around that, but I've given it to you there for revision purposes. So at the bottom of the ladder we have the very smallest units, nanograms. There are smaller units, but you won't tend to find them for this particular purpose. We then have micrograms. Going a bit further up, one more step, milligrams, one more step, grams, and at the top we've got kilograms. You're not likely to find very much prescribed in kilograms, but I've included it because it's such a frequently used unit of measurement. You do really need to be familiar with it and where it sits on this ladder. So each of these units is either 1,000 times larger or smaller than its neighbour, depending on where it sits on the ladder. So for example, there are 1,000 nanograms in 1 microgram. There are 1,000 micrograms in 1 milligram. There are 1,000 milligrams in 1 gram and 1,000 grams in a kilogram. Now the trick is to know whether you're going up and down the ladder and therefore whether you need to multiply or divide. Now for some reason lots of people find this process really counterintuitive, and that includes me. Okay, I can't explain why that is, but you need to know that it is so that you can check yourself and stop and apply your method before you multiply in the wrong direction, because you don't want to be multiplying by a factor of 1,000 the wrong way. That would be very bad. Okay, so it's actually fairly logical. So why our brains tell us it isn't is beyond me, but here's my process for stopping and checking myself and making sure that I've got this right. When converting from a larger unit of measurement to a smaller unit of measurement, you need to multiply. And that makes perfect sense because you need to end up with a much bigger number. If we're converting milligrams to micrograms, the number that we need to end up with needs to be 1,000 times bigger than the number that we started with, so we must have to multiply. Similarly, when converting from a smaller unit of measurement to a larger unit of measurement, for example milligrams to grams, we need to end up with a much smaller number by an order of 1,000. So therefore we need to divide by 1,000. For some reason that is counterintuitive, so I use a little phrase to help myself remember which way to go, and that phrase is Mr. Rabbit died laughing, and I've got my poor little rabbit there just to make that easy to remember. So if we can remember that phrase, those words begin with M, R, D and L. So we can remember MR, multiply, we're going to move the decimal point to the right, and to divide, we're going to move the decimal point to the left in order to multiply or divide those numbers by factors of 10, 100 and finally 1,000. Let's do a quick demonstration here just to show how moving the decimal point helps you convert from one number to another. Here I've got an expanded sequence of digits which are at the moment actually pretty meaningless because we don't know whereabouts in positional notation they sit. There are zeros all over the place. It's really unhelpful. So I'm going to give that number a value by inserting a decimal point here. Again, excuse my horrible wobbly mouse drawing. If that was a coherent looking decimal point, that would mean we had 5 units, 7 tens, 2 hundreds, and therefore the number 275. Once again, having all those zeros on either end mathematically isn't a problem, but clinically for obvious reasons that's horrible. So we're going to start giving names to these zeros now so that you know what they are and how to deal with them. When writing numbers in clinical practice, what we don't want are loads of zeros that don't have a job to do at the beginning or the end of a number. We would need to get rid of them, and in the next couple of slides I will show you how that works in practice. However, if I get rid of my decimal point there and I put my decimal point, let's go here. Okay, we've now got the number 2,750. This zero here is now no longer a trailing zero that we don't want or a leading zero that we don't want. It's got a job to do. It's a placeholder zero. It's telling us that there are no units in this number, and it's doing its job of holding the rest of these digits in their place in that number. So it's called a placeholder zero. Those are really important, and it's really important that you can tell the difference between what kind of zero you're dealing with when presenting a number. Okay, so if I get rid of that one, again we'll go back to my previous example where we have a decimal point here. So here we have 0.275. Technically, this zero here is a leading zero, and mathematically Purely speaking, it's not necessary. However, clinically it's essential because you don't want anybody to be reading that number as 275 because they didn't see your decimal point there. So let's get rid of that one. All right, let's move on and do some of these calculations. Let's stick with the familiar numbers 2, 7 and 5 at the moment. And what I'm going to do here is convert 275 micrograms to milligrams. So before I start to even think about which way a decimal point is going to move, the first thing I'm going to do is write out my 2, my 7 and my 5. And I'm going to pop some leading and trailing zeros onto either side of it. You don't have to do this, but it just helps you keep those zeros in their place. That's a dreadful mess. I am sorry, but that's my best shot with a mouse, I'm afraid. So 275. So our decimal point begins here. Okay, that's where it starts off. And we have some trailing zeros here and we have some leading zeros there. Just gives your brain a little bit less work to do a little bit further on in the process. Our next job now is to work out whether we need to divide or to multiply so that we can work out which way that decimal point needs to go. We're going from micrograms to milligrams, which is a smaller unit to a larger unit. Because there are 1000 micrograms in 1 milligram, I need to end up with a much smaller number here, so I must be dividing. So thinking back to Mr. Rabbit died laughing, DL, divide means we're going to shift that decimal point to the left. And we're going to shift it 3 places to the left, because this is effectively what we're doing. So if I start to draw loops here, which is the easiest way of doing this on pen and paper, if I were to end up with my decimal point there, I would have 27.5 because I've divided by 10. Shift that 1 more space to the left there, I would have 2.75 and I would have divided by 100, but we need to divide by 1000. So 1 more time and our decimal point now ends up there. So now we've got to extract a coherent number from this big mess of loops and points and zeros. So I'm going to show you how to get rid of what we don't need. So first of all, let's get rid of these loops. Let's get rid of the original decimal point so we can see this a little bit more clearly. What we've got here is 0 units, 2 tenths, 7 hundredths and 5 thousandths. We have here a leading zero which has a job to do because it's telling us very clearly that we've got a decimal fraction here, so we wouldn't want that to be misread. All the other zeros, however, we can get rid of. All the leading ones can go and any further trailing ones can also go, which leaves us with our more coherent number 0.275. And to finish the job, and you must finish the job in drug calculations, we have to give our unit of measurement, which is milligrams. So 275 micrograms is equivalent to 0.275 milligrams. Let's move on and do another one. In this one, we're going to convert 0.625 milligrams to micrograms. So again, I'm going to start by writing my number, 0.625, and I'm going to pop some leading zeros on there just to make it a little bit easier to work out what I'm doing. What you don't want is to end up with empty loops because those can end up with forgotten zeros and therefore a very wrong answer. So in this instance, we're going from milligrams to micrograms. We're going down the ladder from a larger unit to a smaller unit. There are many, many more micrograms required to make up the equivalent in milligrams. I need a bigger number, therefore I have to multiply. Mr. Rabbit died laughing, MR multiply, we're going to shift that decimal point to the right. And yes, I do have to do that every single time I do one of these. All right, there's no need to feel embarrassed if you have to use a silly method to help yourself remember what's what. So if we shift our decimal point one place to the right, we've multiplied by 10. By 2 places, we've multiplied by 100, but we need to multiply by 1,000. So our decimal point ends up here. And now, oh, that's not very good, is it? But now we've got to turn this incoherent mess into something that we can read as a legible number. So we need to think about what these zeros are doing. Let's get rid of our loops so we can clear it. And the old decimal point so we can look at it a little bit more clearly. Here we've got 5 units, 2 tens, 6 hundreds. So we've got the number 625. This zero after the decimal point doesn't have a job to do. It's not holding anything in place. It's not telling us anything useful. It's just risking a misreading of that number. Similarly, these zeros here are now just trailing zeros, leading zeros, sorry, with no job to do. So we can get rid of those. We can also get rid of the decimal point and we have 625. To finish the job, we also need to give our units of measurements. Micrograms should always be written out in full, but you can probably imagine how long that would take me to do with a mouse, so I'm going to use the MCG abbreviation there. You shouldn't do that in clinical practice. Okay. Finally, let's have a look at one where the zeros get a little bit more involved. Convert 0.6 milligrams to micrograms. So again, let's start off by drawing our number that we're going to convert from, 0.6. And it's just my way. I like to pop some zeros on either side so that I don't have to worry about empty loops and what the zeros are doing when I've finished. I like to do it all at the start. So now I have to think about whether I need to multiply or divide. Well, this is milligrams to micrograms. It's a larger unit to a smaller unit. I need a bigger number, therefore I need to multiply. Mr. Rabbit, multiply right. We're going to shift that decimal point 3 places to the right. Okay, so multiply by 10. Multiply by 100, multiply by 1000, and our decimal point ends up here. So now we have the tidy up job to do. So let's get rid of our loops. Let's get rid of the old decimal point there. So now with our decimal point here, we've got 0 units, 0 tens, and 6 hundreds, giving us the number 600. These leading zeros now don't have a job to do, but these ones here, these two absolutely do. These are placeholders. This is our units and our tens column, giving that 6 its value of 600. We can get rid of the decimal point there, and we need to finish off by giving our unit of measurement. Again, should be written out in full, but you don't want to sit and watch me go through that. So I'm just going to put MCG there. Okay, so that draws to a conclusion the moving the decimal point method for converting between the metric units you'll commonly find in drug calculations. There are some next steps that you do need to take because that really isn't the be all and end all of this particular skill. So you need to complete the rest of this Moodle lesson. There are further resources that I've put in there, further videos, little tutorials that will help expand on some of those concepts that are done really, really well, and it's well worth your time to watch them. There are some quizzes in there that will help you test your skills and to make sure that you've followed each concept as we've worked through it. So do please, first of all, finish this Moodle lesson. It's also really essential that you use that learning module on Safe Medicate. It is a learning tool as well as an assessment tool, and the information in prescriptions and SI units, in particular the tutorial for how to convert SI units, is excellent. They have many more tools available to them in terms of instructional design than I have available to me. It's a commercial product, therefore they really do an excellent job. So please make sure that you're making full use of that resource. There is a resource in this Moodle section called Test Yourself Unit Conversions. It's an Excel spreadsheet that you can use to practice to your heart's content unlimited conversions with micrograms to milligrams, grams to milligrams, micrograms to milligrams, etc. You can just practice and practice and practice and keep refreshing those numbers. If you want to contact me for quick instructions on how to use it, then I'm happy to talk you through that, but its instructions are available on that for you. Finally, practice, practice, practice. This is not a skill that develops overnight. I've been doing this for years and I still have to think about Mr. Rabbit. All right, so lots and lots of practice will help you be as safe as possible when doing these really crucial calculations. If you want to email me for further support or tutorials, feel free to do so. There's my email address, karen.hudson@essex.ac.uk, and I'll be happy to help you further. And finally, I just want to leave you with a quote from my days learning musical instruments, which is that an amateur will practice until they can get something right. However, a professional will practice until they can't get it wrong. And that's what you need to be aiming for, 100% accuracy in your unit conversions every time. I hope that's been helpful. Again, please do contact me if you've got any further queries. And until next time, we'll see you later.